today, what I want to do is I want to crank through section 1.8. That'll close us up with chapter 1. We'll get you guys the rest of the problem set assigned, talk about next week a little bit, and then we are going to be doing the another Delta Math assignment afterwards. Sophia? Sure. Go right ahead. Do you remember how everything is? Hey!
Oh, my dog is He's a puppy.
It's hanging down there. There you go. Yep.
You're dumb, so I don't know.
Hey,
Whoa!
easy on it.
His language. I think it's me for using my planner. What?
God, it's steamy in here.
Sorry.
Just remember.
I know I'm good looking, but. All right. Graphical transformations. Okay. Let's remember all the way back to geometry. What are the 4 types of transformations? Reflection is translation. Okay. What's the technical term for a stretch?
Expansion.
Dilation. Good.
Rotation.
And rotation is the 3rd, yeah, or 4th. We'll do that later. Yeah, I'll take a question later. All right. Of these, rotation beyond the scope of this course. So really today when we talk about graphical transformations, we're going to take these 3 geometric ideas and apply them algebraically. Everybody okay?
Wait, why was rotation crossed out?
Beyond the scope of this class.
All right.
Reflection. We're only going to worry about 2 types of reflections. What do you suppose they are? Yeah, so across the x-axis and y-axis. You got it, dudes. And translations, what are we doing there? Up, down, or left, right. And dilation, so stretching and shrinking, but yeah, so we can have a vertical stretch or a vertical shrink, and then a horizontal stretch and a horizontal shrink. So those are the 6 types of transformations we're going to worry about algebraically. Okay. So when we talk about transformations, oftentimes we talk about 2 types of functions. One's called a parent function, the other is called the resultant function. So if y equals f of x is our parent function, then y equals a times f of 1 over c times x minus h plus k is the resultant function. This form, it'll be super important, so that's one that you'll definitely want to kind of commit to memory. We will use that form a lot, both in this chapter and then moving forward. That's a good one to make sure that you know. You probably already do from your Algebra 2 course, because all the function forms were basically, the general forms are kind of that already. But if you don't, that's a good one to kind of hang on to. All right, let's talk here then about each one of these different types of transformations. So we have 2 types of reflections. we said we can reflect across the x-axis. That happens when the sign for A is negative. And we can also reflect across the y-axis. This happens when the sign for C is negative. Yes.
The definition, what does RF stand for?
Resultant function? Yeah. What? Parent function. So like it's the beginning and after. It's like before and after. Like before the transformation, after the transformation.
Oh, wait, and what's the RF again?
Resultant.
Okay, thank you.
You're welcome. All right, so let's say that we have the function f of x is negative 3x squared plus 4x minus 1, and we're wanting to transform or translate that or transform that as a reflection across the x-axis. So the a, I'm going to make negative 1, and then all the other pieces I'm just going to pick their null values for. So the multiplicative pieces are going to be 1, and the additive pieces will be zeros, because that won't do anything. So my resultant function, g of x, will be negative f of x. So that would be negative of negative 3x squared plus 4x minus 1, or 3x squared minus 4x plus 1. And if you graph the two on the same xy axis, you'd see that g of x is the reflection across the x-axis of f of x. And that's all that it is. So if I want to reflect across the y-axis, this time that c value I know needs to be negative. And the other values I'll just pick their null values for. So the multiplicative pieces will be 1s and the additive pieces will be zeros. So my g of x then would be f of negative x, which would be negative 3 times negative x squared plus negative, 4 times negative x minus 1, which is negative 3x squared minus 4x minus 1. And if I had to graph that, I would again, if I graphed f of x and that g of x, I would see that they are reflections of each other across the y-axis. Everybody's cool? So far, so good? Okay. So let's now look at the dilations. So again, we had two types. We had horizontal, stretch or shrink. So if that C value is greater than 1, that's a horizontal stretch. And maybe I should say the magnitude of the C value greater than 1. And if it's less than 1, it's a horizontal shrink. And then we have vertical stretches and shrinks. This is going to be controlled by the magnitude of the A value. And maybe let's say be a little bit more specific. Okay. So notice that I don't include the case where the magnitude of A or C is exactly 1. Why not? No dilation occurs, right? That's the nulls case where nothing is happening. Right? So let's look at an example here. Let's take that same f of x that we were using before and say we had a vertical stretch of 3. So since it's a vertical stretch of 3, that tells me the A was 3, and everything else should just be kind of its null values. So my transformation would just be 3 times f of x Everybody okay there? And if you graph both of those, you notice that like the g of x would be like stretched vertically. It'd be like skinnier and increasing faster, right? Sophia? Well, is there anything happening horizontally? So the null values, anything that's multiplicative, like A and C would be 1, and additive would be 0, so like H and K, if nothing is going on. Because if we go back and we look at the resultant function, right, like A and C are multiplicative, those should be 1s if nothing's going on, and H and K are additive. Those would be 0s if nothing's going on. Does that make sense? And again, if you're not sure why something is the way it is, or you need a question, stop me and ask. It is okay.
Wouldn't H or K be negative 1 because you're subtracting?
No, 0 is still doing nothing if you subtract. Right? If you want to subtract nothing, that's 0, right? So just still H and K are 0s. Okay. So let's say that the horizontal shrink is 1/2. Since it's horizontal, I know we're talking about the H. And since it's shrinking, I know that it should be a number less than 1. So we got 1/2 there. Nothing's happening vertically and no translations are going on. So the H and K are 0 and the A is 1. So my g of x should be f of 1 over c times x. And what's 1 over 1/2 the same as? 2. So I'm going to have negative 3 times 2x squared plus 4 times 2x minus 1, which is going to be negative 12x squared plus 8x minus 1. Everybody good with the negative 12? quantity 2x squared is 4x squared, and then times the negative 3 gives me the negative 12. Got to remember to square the coefficient in there. Sometimes that gets forgotten. Try not to forget. Okay. Let's talk about the translations next. Notice that the A and the C covered both reflections and dilations, right? The sign on A and C indicated the reflection, and then the magnitude, the relative size of A and C handled the dilation. We had two types of translations. We have a horizontal translation. So if the H is greater than 0, we're going to be going right H units. And if H is less than 0, we're going to be going left H units. Maybe I'll call that shift. That's probably the verb that I use most often. And the vertical shift is going to be handled by the K's. So if K is positive, we're going up K units. And if K is negative, we're going to go down K units. So let's take our same f of x from before, and let's say we want to shift up 4 units. That tells me the k is what's changing because we're talking about up and down, so the k should be 4. And then everything else should just be its null value. So here g of x should be f of x plus 4. So negative 3x squared plus 4x minus 1 plus 4. Negative 3x squared plus 4x plus 4. If we want to shift left 1 unit, so since we're talking about left and right, we know we're talking about the h's. Since it's left, I know it's negative, and then 1 unit. And then everything else stays the same. So this is going to be f of x minus a negative 1. Remember, what's minus a negative 1 the same as? Plus 1. So when I want to do x plus 1 squared, is that just x squared plus 1? No! What do I have to do? FOIL! Ah, Mr. Kulik, I'm just going to FOIL it in my head if you guys are okay with that. I hope that would be the case. I don't know if you're actually talking to me or not. No, you weren't, but that's okay with me too. What do you think, Jacob?
For A, there's like negative 1 plus 4, because that's supposed to be 3.
Oh, sure is. Here, let's write that in green so everybody can see the error of my ways. Talika, was that the same? Thank you for paying attention, guys. Again, if you catch me making mistakes, you let me know about it. And even if they're not mistakes and you're just like mistaken, that's okay. Like if you think something's wrong, you say, speak up. No reason to keep quiet on that. Okay. Next question here that we're going to deal with is, does the order of the transformation matter? So take, for example, say we have just the parent function of x squared. And let's say we want to do, we're going to shift up 3 and then go vertical stretch by 2. And then in the next example, we're going to swap the order of those and see if we get the same function both times. Since we're talking about going up 3, that means the k is 3. And then everything else is the null value. And if we're doing then a vertical stretch by 2, that tells me the a should be 2. And then everything else should be its null value. So the first step in my transformation should just be f of x plus 3, or x squared plus 3. And then the second step in my transformation should be 2 times the previous step, which is 2x squared plus 6. Everybody okay there? Let's see what happens if we swap them. Does the order matter that I apply these transformations? What do you guys think? Yes, of course the order matters, Mr. Gulick. Well, okay, that kind of steals my thunder. That's okay. It's not like I'm Lord of Thunder over here. So just kind of doing the same thing I did before. And again, what we want to notice is that we got different values. Oh no! So we need to agree on, when we talk about doing a bunch of transformations to the same problem, we need to standardize the order that we're talking about, right? So this is the order of transformations. Oops. Put an S in there. So the first thing, reflection on the y-axis. Two, the horizontal, stretch or shrink. Three, reflection across the x-axis. 4 would be the vertical, stretch or shrink. 5 is going to be the horizontal shift, and 6 would be the vertical shift. Yes, Nolan?
Are 1 and 2 interchangeable?
Yeah, to some extent, but this is the order that we're going to write them when we write them. Woo, that was a big one, guys. Yeah.
So I guys know that Queen Elizabeth has died. Yeah.
No.
Because this morning, she was sick, they're talking about whatever, and then 10 minutes later, they reported that she died.
Oh
I
my God, dang. That's
Well, I hope I don't get whatever she had.
Interrupted with lies.
We're only
96 years old. How old do you think she was?
Everybody always like talked about how she was like the oldest long.
96.
She was like 120. No, she always said how she was like so old.
No, nobody's like 120. Dang.
I feel bad.
Have you seen like
No, she has 96 years.
Her kids are like in their 70s.
Oh, she
Well,
like
it's like Prince,
3 World Wars. Why would you feel bad?
Oh, yeah. Wow.
Do that organ. She just can't. Wait, so who's the new king or queen? Where's Charles?
Yeah, Charles is the next in line, I think. All right. Again, I just summarized what we had written before there. Right? That's nothing new that I wrote in red. Just like putting it all in one place for you, basically. Is everybody okay with that? Is this something you need to know? Yeah. You got to know the order and the criteria. Probably a lot of us know these already, right? Because this is the same criteria you would have seen for the most part in your Algebra 2 course when you talked about your general function for the function class. All right. So let's look at an example here. Let's say our parent function is x cubed, and our transformation is 2 times the quantity x plus 1 cubed plus 3. If I want to describe this transformation using the proper order, the first thing I have to do is pull the values for a, c, h, and k from my equation. To do that, I'm just basically going to be using the general form. Everybody's cool with that? And in this case, my f is just the cubed, right? Because my f is x cubed. Everybody's cool with seeing that? Okay, so what's my value for A? 2. What's my value for C? 1. What's my value for H? -1. Very good. And value for K is?
4.
Everybody cool with how we read those values from the equation? Yes,
Is
Paul.
he the coefficient?
So C would be like the coefficient here,
All right.
which in this case, you could write a 1/1 in there.
Thank you.
Yep. All right. So I noticed that the C value is greater than 0, so we have no reflection across the x-axis. Since the absolute value of C is equal to 1, we have no horizontal stretch or shrink. Since the A value is greater than 1, we have no reflection on the, oh my goodness, that's a y-axis there, Mr. Kulik. This is the x-axis one. Yay. I caught it before you guys did, though. Since the absolute value of A is greater than 1, we have a vertical stretch, in this case by 2, a factor of 2. Since H is negative, we're going left and then 1 unit. And since K is positive, we're going to go up 4 units. So that's what I would write if I asked you for the order of transformations for that g of x. So even if nothing's happening, you should write that nothing happened. Right? Like 3 of these, there's nothing going on. We still wrote that nothing was happening for that, though. Rita.
So I like the H value. How come it's -1 and not 1?
Because it's minus h in the formula.
Oh.
So,
The original formula.
yep. So the +1 must have been minus a -1
Oh.
in my black g of x to write it in the same form as the red one. Do you see it?
Yeah.
Will it always be that way, Mr. Kulik, where the h is the opposite sign I think it's going to be? Yup. Thomas.
Can the F like switch spots in the formula?
Can the f switch spots in the formula?
Because like in the first one it's AF, and then it's 1/c, and then this one.
Oh, shoot. Yeah, I wrote that wrong, didn't I? Thank you. Here. Put it in the blue. Thank you. Thomas just pointed out that I wrote something in the wrong order. Thank you, Thomas. Earlier is better if you're catching my mistakes, but that's okay. I'm glad you caught it at some point, because I would have just blown right past it. That's an important detail that I did mess up. Made it really confusing looking, right?
Why would F be it's not even the same side as the
My f of x is x cubed. Right? Yeah. Those are coughs, no blessing needed. All right. Here's the next one. So have I.
my whole
That's not an accomplishment.
I know. I just started for like 5 years. If I guess it's 9 months.
Okay. Everybody, we're going to do the same thing. Actually, I'm just going to pull the values for A, C, H, and K, and then we're going to skip writing the order because it's just like a lot of writing. Is that cool with you guys? Christian, do you have a question? Okay. I didn't know if that was a hand or not. Okay. All right. The value for A is? The value for C is? No. 1/2 is correct. So
what did you just do there? Yeah, what did you just do?
Factor out the two.
Because the general form is,
C is the denominator of the
Alright.
factor, and so if it was 2, that means that you had to put a 1 past.
So here's the deal. C is the reciprocal of the coefficient. That's all that we're saying.
So it's 1 half.
So it's 1/2,
Why did you put it 1 over 1?
because that's the same thing as 2.
Oh.
2 is 1 over 1/2. But I don't really need to write it like that. When Nolan said it was 1/2, that's not the way he was thinking about it. He was just thinking that the coefficient is the reciprocal of C.
Yes, sir.
That's the easy way to think about it. Will it always be that way? Yeah.
Wait, what's when you done? Oh, okay. The coefficient's 2.
This
He's just trying to figure out.
is saying C is the reciprocal of the coefficient, right? So since that coefficient there was 2, the C value is 1/2, because I need to write it as like 1 over 1/2, right?
I genuinely like that a lot.
And then H is 2. We have to look at the factored form. Oh, man. And the K is -2. So you got to be careful on that C and H piece, right? Got to factor stuff. Got to be careful. It's easy to mess that up. Everybody okay?
Yeah.
Okay. And you could write the order from there. That would be no problem, right?
What do we do like with the f of x equals the square root of x?
That told you what the parent function was.
So we can see.
So you could see what the transformation was. If the parent function was funky, like we're going to do in the next example, it's nowhere near as clear. Okay, so let's look at an example like that where the parent function is a little funky. Yeah, we did, but it just told us that like that nothing really, we didn't really need to have to do anything. Like that needs to be there in order to make this easy.
Guys, I can't go to cross country. I have to mourn my pool.
She is my queen.
Not after 1776. Unless you have Canadian citizenship or something also.
Well, it's more about it's subjective.
Are you part of the Commonwealth?
Yes.
Yeah.
I need to agree.
All right. So for all of you that were like, what did I need the f of x for? Well, in the previous problem, the f of x just told you that everything is basically what it looks like. The transformations are easy to come up with. In this problem, our f of x is funky. It's going to be nowhere near as easy to just come up with the transformation. We're going to have to be very careful about this. All right. So the way that I'm going to do this is I'm going to think about this as 6 steps. If I look at this, the first step I need to consider is the reflection across the y-axis. If I look at g of x, I'm going to be looking for the c coefficient. That's the thing that's going to be attached to the x. What do you notice here? Yeah. So we saw no reflection across the y-axis. So my first transformation is I did nothing, right? The next thing we do is we look for horizontal dilations. Again, no coefficient on the x. So nothing happened. Everybody's okay there? Okay. So that's all coming from just my observation that there's no coefficient on the x. Next thing I need to do is I need to be looking at the a, right? The first thing I'm going to do is look at the sign of the a. Going from F to G, did the sign change? Yes. And so we'll do that. And finally, I'm going to do this. I think it'll probably be easier to do it one step at a time. I'm going to make some space here, I guess. Ugh. Okay. Next thing I'm going to do is worry about the vertical stretches and shrinks. Again, using the k. My k is gone, or my coefficient there has gone from 2 to 6, since we already dealt with the negative part. So what was the a value? 3, right? Everybody so far so good? Now we're going to look at the h. What part is going to tell me about my h? Yeah, anything added or subtracted directly to my x. So my h is +1. Or I'm sorry, not +1, it's -1. Everybody's okay here? The last step is to account for the k. So in my final, I need to be at -1. Where am I at right now? +9, right? Everybody see that? So what does the k need to be? -10. Yep, I just wanted to finish my thought here. So I need to get down to -1 out back, right? That's the k value over here. Right now it's currently at 9. since we've changed the k value along the way, I can't go back and look at f of x. I need to look at where I'm at currently. Because when I changed the a, that changed that number out back. So that's why it's negative 10. Does that feel okay? What do you guys think? So this is like my answer of the transformation, right? These ones tend to be the trickiest ones when you're given a funky looking parent function and then try to figure out the transformation. The trick is to do it just like one little piece at a time, go through in the proper order, look at the two functions, just try to peel it off one layer at a time. Is there a way to check? So if I do g of x equal to negative 3 f of x minus, well, let's write it all in there, 1 over 1 times x minus negative 1 minus 10, that better come out to be the g of x that I cited above, right? So plugging this in, that was minus 3. Okay. So let me distribute through. Everybody see that? So I just went and took my values for A, C, H, and K that I came up with above. I plugged them into my general transformation formula. I grinded that through, plugging those things into f of x appropriately. And notice it does give me the g of x quoted at the start of the problem, right? Oh, sure, of course.
Wasn't the g of x negative 6?
Oh, yeah. That's because I'm dumb. What did I do wrong? Yeah, I forgot the 2. Thanks, Nolan. It's the end of the day, guys. Mr. Kulik's making mistakes. Ooh. They're not procedural mistakes. They're just like, yeah, I'm clearly so distraught. Probably going to call in sick for the rest of the week. Just like I just can't bear. I mean, what's the legislative power of Britain going to be now without a queen? You know?
So, can you just go up for like 1 second? Just a little bit more. Okay, I'm good. Thank you.
Sure.
Switch it to Britain.
All right. So let's say that we have our parent function here defined as f of x, only defined with the graph, and say we want to graph the resultant function g of x that's equal to 2 times f of x plus 3 minus 1. I'm still going to want to start by identifying the values for a, c, h, and k. What's my value for a? 2. What's my value for c? 1. What's my value for h? -3. And what's my value for k? -1. Now somehow I need to use this to transform the stuff in red. Here's the key idea. That this transformation is equivalent to this map. This guy is a good one that you'll want to remember. So that map is going to describe how I transform the points in f of x into the points in g of x.
Could you read it out loud?
xy goes to cx plus h, comma, ay plus k. So the c in our case was 1. The h in our case was -3. The a in this case was 2. And the k in this case was -1. So I'm just going to apply this transformation to each of the 4 points given in my picture. And then I'll plot my new 4 points and connect them. Oh, Mr. Kulak, that's not so bad. So -2 plus 3 or minus 3 is -5. And then 0 minus 1 is -1. And then 0 minus 3 is -3. -2 times 2 is -4, and plus 1 is -3. Oops, sorry, that's plus a -1. 2 minus 3 is -1. 0 minus 1 is -1. 4 minus 3 is 1. 2 times 4 is 8, and then minus 1 more is 7. So these are going to be the 4 new points that I'm going to be graphing to get my g of x. So let's see, 1, 2, 3, 4, 5. And then 1, 2, 3, 1, 2, 3, 4, 5. Then -1, 1. And then 1, 7. So 1, 2, 3, 4, 5, 6. Oh no! Didn't leave myself enough space. That's pretty good. 1, 2, 3, 4, 5, 6, 7. Try to do a better job on that. There's g of x. Pretty easy, right, when you think about it that way? The key is having that function map. So again, cx plus h, ay plus k. That's our tool for transforming the coordinates of f of x into the coordinates for g of x. Neat. I'll take it. Yes, of course. All right. How do you guys feel? Horrible. I'm sorry to hear that. So that will allow us to finish up and get to 66. Let's recap here. For Sunday, what I'm going to be looking for is 31 to 56. That's Sunday the 8th. Nope. Sorry, the 11th. Wrong date. And the following Sunday, the 18th, we're going to be going 57 to 66 plus the review, which again, if you look in the My Notre Dame, there's a review packet as well as worked out solutions for the review packet. Everybody okay there? Hi.
Do you ever like post the even answers, like so I can check over like all of my stuff?
Nope.
Okay.
I'm just being honest. I'd like, and my reasoning is if I do that, digital things have a life of their own and tend to live on in perpetuity. So next year's students will likely have all the even answers before they do the work,
Oh,
and which turns into just like I'm just copying a bunch of stuff down,
yeah.
which is why you guys have the odds, but not necessarily all the events. And I hope you understand like my reasoning for not wanting to share all of it. Yeah. Yes, Rita.
So when is that test?
When was the test? I have the test scheduled for next class, right? But that's probably a problem, right? Monday's a mass day, isn't it? Yeah. So let's just bump that a class period. We'll just start the next chapter on Monday and then do the test on the following class. Is that
Thank you.
Wednesday then, instead of Monday? Is that okay, Nolan?
Will transformation be on the test?
Yes.
The one that's not sure already.
So what's that for you guys? 9:15 then, or 14?
The color is. Wait, what is it? What are the words saying? Usually.
Shh.
Wow. Oh, no.
Excuse me. Thank you. All right. So everybody's okay so far with the dates? Let's talk on Monday about the test details, right? You guys can work through the review at your leisure, but remind me Monday and we'll talk about the test format and like the kinds of questions and numbers of questions. The review is a pretty good semblance of what the test would look like, much shorter. The test would be much shorter than the review, but we'll give you some like specifics on Monday if you can remind me. Does that sound good? Who's going to be in charge of doing that? Sophia, remind me on Monday to talk about the test. Okay. I ask because you're always like, I have homework questions. That's why I picked you. It's okay. I'm not picking on you. I'm just saying that like you're gonna ask me something at the start of class anyway. So like, let's do it at the start of class. And it's okay. I'm glad that you're doing it. Is everybody on board with that? Okay. At this point, I will answer some homework questions if you want, but if you are, if you're good with homework questions, You do have a Delta Math assignment? Hold on, guys. I haven't even had a chance to explain everything yet. You're already like, wait a minute, we have. It's like, well, just give me a second. So you go to your Delta Math. Your looks different than me. So your Delta Math assignment should be titled 121416. Okay? And it's set up the same way as as the previous one, where there's just a set of randomly occurring questions. You get 2 tries per question. If you get it wrong, there's no penalty. You just have to keep going until you've gotten 10 correct. And I think I set the due date for that as Friday at midnight. So we have it to do. We can start now. Yes, tomorrow. Isn't tomorrow Friday? Okay. Yes. Certainly.
Wait, it says September 17th. Yeah, it's
Next Friday? Well, I don't know. Did I put the wrong date in there? I don't. Well, I don't want it to be due next Friday.
Why?
Why? Because I want you to do it before the test. How about
Sunday night.
here, Monday 8 a.m.
Okay.
Monday 8 a.m. Deal? Fine? Nobody's mad now? Look at me. Look at me. Remember this. Okay, when you complain about my class, be like, at least when I complain, he does stuff.
Yeah.
Right? There's lots of work, and I'm mad about that. But at least when I complain about when it's due, he listens to me and he'll do stuff. Right? So we move the test back. We move this back. That's fine. I don't care when stuff is due. It's okay. Well, to an extent. Like, we have to have due dates at some point. But, like, if this makes life a little bit easier, that's fine. There you go. All right. Okay. So if you are uninterested in homework questions, you can start your Delta Math assignment, or just take your brain break or whatever else you need to be doing right now that's more important to you. If you have homework questions, Sophia, I am happy to do whatever you want to, or talk about whatever you want to talk about right now. Thank you for waiting patiently. I just had a feeling that I don't want to get shortchanged on getting through all that we needed to kind of get through.
For this problem on the homework, the equation is y equals 10 minus 4 times square root of x
Okay.
plus 5. This is the graph, and it said that the domain was negative 5/7, comma, infinity.
That
typo?
seems like a mistake.
Yeah, I just wondered.
Yeah, which number is that?
47.
47, you say?
Yeah.
Okay. All right. Sophia, you were asking about which one? 47. So stop talking. Yes. So your issue is that the answer and the key doesn't match the question, right?
No, I just like to go ahead and do it.
Oh, okay. Well, just so you know, the answer in part B in the answers is wrong. So if you get if you get the wrong answer there, that's okay, because
For which question? 47.
so that's okay.
Oh, the domain.
Yeah, for part B, the domain should be what should be? Should be -5 to positive infinity, right? And then the range should be -infinity to 10. That should be the correct answer for part B.
So for every single problem, can I just look at the equation? I can get my domain ranges from the equation.
Or from the graph on your calculator. Doesn't say how to do it, right? That's okay. Is that good?
Yeah.
Was there more that you wanted to ask about 47, or was it just specifically part B where my answer was wrong?
Did you do the 52 that you
Answer my question.
Sure. So we'll subtract 8 first to get the log by itself. How do I cancel out just a regular old log? Well, I should say, what's the best way to cancel out a regular old log? Exponent base, not 1, not 0. 10. Regular old log, common log is log base 10. And then I can add the 1 over and then swap the x's and y's. So that's my inverse there, Sophia, for 52. And then that's 52e. Giselle.
Could you do 49 E?
49e? Sure. So the first step, we're going to multiply both sides by x minus 1 to get rid of the fraction. I'm going to distribute the y. Then I move the stuff with x's onto one side by subtracting x from both sides, and move the stuff without x's to the other side by adding y to both sides. Notice on the left-hand side now there's a greatest common factor of x. So I'll factor that off. And then I'll divide by y minus 1. And when I swap the x's and y's, what do I notice? What do you notice? It's the same as f of x. This function is its own inverse. Whoa! Bet you didn't think that could happen. That's pretty neat. Surprising, right?
Yeah.
You definitely look at that answer and you're like, well, I did that wrong. How did I get the exact same thing I started with? If you checked it and tried to do the composition, it does indeed work, which is pretty neat. Are you happy with that, Giselle?
Yeah.
Okay. Did you get the same thing and we're like, wait a minute, what happened?
Yeah, I was just a little confused, but now it makes sense. So.
Yeah, no problem. Sophia.
What was the domain range
For
for
48, the domain would be, let's just write it down here. Negative infinity to -4, union -4 to positive infinity. So everything but -4. And the range would be negative infinity to -9, and then -9 to positive infinity. So everything except for -9. And again, if you remembered simple rational functions from last year, you could have looked at that and pulled the domain and range without even doing anything.
Yeah.
Probably would have wanted to look at the graph though. Rita!
It's like on Delta Math, like for like the minimum and maximum values, how come like it doesn't like want a point? Like I put like a point in and I got it wrong. Like the So how about minimum? Yeah, why do you just?
Ah, so it's a vocab thing.
Like, how do you know when to just put the y value, when to put like a
So if we're talking about an extrema, that's a point. If you're talking about the minimum of a function, that's a y value, like the function's output.
So minimum of a function is just y value, and then what's the...
An extrema is a point.
So like, what would like an example?
I can't hear you over everyone
Like,
else.
what would like an example for like a question or like an example?
Like, what are the extrema for this function?
Oh,
So like, list the extrema. So you'd write like blah 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 is a minimum or whatever.
Who did you throw that? That's so creepy.
Do you have a document assignment?
Yes.
Like there, or is it like?
You go to Delta Math and there's an assignment made for like if you look at your assignments or whatever. I don't know what your view looks like. Very good. But
Yeah, I see.
Creepy.
I